Hello everybody, this is Rahat Naqvi, Seismic QC Geophysicist from Pakistan. In this video, I will share the general overview of seismic crew and seismic field operations, particularly onshore. When we talk about the contents of the seismic field, we can generally divide into three parts. Firstly, general description of the exploration criteria or general description of the seismic acquisition, and second thing would be the field operations, and third would be that how does the quality control department of the crew works. Seismic exploration can be divided into three categories: seismic data acquisition, seismic data processing, and seismic data interpretation. This works in the order, and some people may add well drilling into seismic exploration as well, which is equally fine. Here we can see the seismic acquisition survey flowchart. The seismic acquisition survey starts with the designing of the project, and all the design project is usually done by the QC section. And after the designing, it is given to the service section, who will stake out the resources and receiver points on ground. And then the cable crew will lay out the receiver line equipments on receiver points. And afterward, we will use the sources. Our sources are of two types majorly. One is the Dynamite and the other is Vibrator, which we will discuss further. And these sources will produce energy in subsurface to record the data, and the data is recorded in the recording truck. After that, this data is handed over to the QC section, and the QC geophysicist is responsible to check the verification of the data and check that either all the recording parameters are fine or not, and after that the QC department transmit the data to the client for further processing. In some cases, crew receives the design project, all the coordinates of the whole project, and then they simply deploy their field teams for surveying operations. But most of the time, crew management receives the start and end coordinates of the project or block boundary coordinates along with other acquisition parameters. In this way, crew QC department, under the supervision of client, used to design the project and gets approval from the client for further application. If we see in this picture, we can see the blue and red dots, which represents the receivers and source points respectively. The blue is for receivers, and the red dots represent the source points. In some points, these source points are also called VPs, vibrator points, depending on the types of sources. These receiver points makes the receiver line, and the source points make the source lines. All these source lines and receiver lines, source points and receiver points are well designed, and they are at regular intervals, so we can see that okay, there is no any hindrance. So basically, because they are the design project, when we will deploy on the field, we will see that if there is any hindrance, it might be changed, so depending on the situation. So when we design this project, after that QC section used to share the design project with the service section for application on field. That was the general description of the seismic crew. Now we will talk about the field operations and the equipments that we used in the seismic field. Prior to deployment of field teams, crew management visits the operational area, which is technically called as scouting of the area. So the scout teams used to scout the area, and they examine the terrain conditions. Either there are some mountains, forest, cultivation, population, photo region, any type of terrain, and then they have to decide that which kind of equipment is needed and in how much quantity is needed, and what kind of personnel and professionals are required to to work in this area. It is very necessary and it's the part of the planning. Once the scouting of the particular area is done, scouting team which works under the service section, they submit report to crew management, and crew management decide that which kind of resources we needed. Let's say if the dozer is needed, then the dozers are deployed, who works under the supervision of the dozer, dozer pusher and dozer supervisors, and they carry out work in such a way that there shouldn't be any hindrance in the field operations, and also they try their level best to carry out the safe operations. Once the pathways are cleared by dozers, then the service section they send their guys to stack out the source and receiver points on ground using GPS system. And in GPS system, a base station is established using the static technique most of the time, which catches the signal from satellites. And the number of satellites depends upon the area. In different areas of the world, the number of satellites should be different. And they transfer it to RTK rover in the backpack surveyor guy, which uses the GPS controller to stack out the receiver and source positions. If the GPS guy is working in the area where they cannot get signals and the signal quality is poor, in those cases they try to establish one small base station, which in the survey terminology is called as repeater. Repeater gets the signal from the base station, enhances it and transfer it to the GPS operator. In this way they can work in a better way. Apart from some other survey equipments, these two equipments are very important for the surveying operation. One is the GPS receiver and the other is the GPS controller. The left one, Trimble 5700, is the GPS receiver. It catches the signal from the satellites or from the base station, and then the GPS controller on the right side is used to stack out the point where the surveyor is standing, and they get the position they are looking for. This is how the sources and receiver look like on ground. The blue band pack shows the receiver point, and the red band pack shows for the source point or the VPs. It may change in different parts of the world depending on the need. Even in some areas of the world, usually the sources are not marked, or not stacked out, or not surveyed. Or even if they are surveyed maybe each 100 or each 10, or start of line and end of line. Here we can see the cable crew working in the field. Cable crew is responsible for all the layout of the recording line equipment. They verify the connections and also troubleshoot during the seismic data acquisition. And once the seismic data acquisition is done, then they pick up all the recording line equipment from that particular swath or that particular line in cases of 2D. This cable crew they do each kind of job that is related to seismic cables and geophones and each kind of recording line equipment. In the base camp, cable crew have established one cable shop which receives all the line equipment from the field teams. They receive, and after that they carry out some tests on the geophone strings and also test the cables, that whether they are working well, and they check certain parameters according to the manufacturer specification. And once the test has been done, they check if the test is passed, then they can again take back to the field and lay out the equipment, and the things goes on. There are two basic types of seismic sensors, geophones and hydrophones. Geophones are used for land acquisition and hydrophones are used in water bodies. On the left side we can see the geophone string, which is comprised of the 12 geophones, and in the center we can see the hydrophone, which is a single unit used for 1 RP, 1 receiver point. On the next we have the links of the FDUs. Basically we can see that 3 FDUs are attached to one recording cable, and one FDU belongs to one geophone string. So once we lay out the geophone string on the ground, it is connected to one FDU, which is part of the seismic recording cable. Each third cable is most of the time is linked to loud line acquisition unit, which is attached to a battery of 12 volt. Next we have the logs. Logs is used to connect the seismic line with each other and to the recorder in case of 3D survey, usually at intersections. But when we talk about a 2D survey, then the logs is used to connect the seismic line to the recorder. These are the basic recording line equipments which are used in the seismic operation. Here we can see the whole recording operation. On the top right side we can see a string of 12 geophones which is connected to an FDU, and then FDU is connected to LOL, and LOL is attached with the battery to support the whole recording line with power, and then afterwards it is connected to one logs, and the logs is attached to the recording truck. So this is a conventional seismic recording system. From the logs we can see the high side, it means the end of the line, and the low side means the beginning or the start of the line. So these both part of the lines are connected to logs, which is connected with the recording truck, and it records the data and saves it. Seismic sources are used to produce seismic energy into the subsurface, which results in the seismic reflection and seismic reflection data. There are two types of sources that are used widely throughout the world. One is impulsive and the second is non-impulsive. In the non-impulsive, it's a control source, and the most popular in the non-impulsive is the vibroseis. Some other types of the sources in the non-impulsive or control sources are hammer or also, but also nowadays some sources are also developing, but it's not in the market yet. When we talk about the vibrator, depending on the areas and some other specifications, different numbers of vibrators are used in one fleet for one VP. It might be 1, it might be 2, it might be 4, depending that how much energy is required to transmit in the subsurface, and how much noises are there, and so many other parameters. So we will discuss sometime in a different PPT that how the source parameters are selected and how it works. But when we talk about the impulsive or uncontrolled source, then we use explosive. In that case, we have to drill the hole. Drilling up the hole is a bit difficult job. We use different kinds of machines to drill the hole at different depths. Somewhere we just need maybe 2 meters or maybe 1.5 meters, but somewhere we also need to drill maybe 10 meters or more than 10 meters. The accessibility of the drilling machines is always a big difficult task as well. Then we have to use the explosive, and dynamite and some detonator to blow it out. And after that, once we blow this hole, uh, then the energy is produced and the data is recorded in the seismic chart. So generally speaking, we can say that we have two types of sources, dynamite and vibrators. Here we can see a conventional seismic recording truck outside and inside. On the top left, we can see the recording truck and antenna. In the picture below, we can see on the leftmost, we can see the active supply, active line, or we can see the geophones, and then we can see the different parameters of the different geophone strings. And once we record, on the right side we have a sample record that okay, this kind of the data we usually receive in our recording system. Once the data is recorded, the data is brought back to crew and handed over to the QC section. The QC section checks all the documents and then share it with the crew QC processor. QC processor upload the data in the processing machine and check the QC parameters, check the geometry, and apply the recorded SPS and check that how's the validity and whether they are recorded on their original positions, they made some offset, either they made some mistake or whatever. And after that, so we can see that is the leftmost, top leftmost, and then on the right side we can simply save one blue stack, and on the downside we can just see one picture of the same blue stack, but we have applied some density modes and applications. Crew QC department is very important in all aspects in designing the project and sharing the project with survey and then deployment of all the field activities and technical support to all the crews. They have already developed some QC procedures which they implement in different sections of the crew. And once the data is received, then they communicate with clients regarding all the obstacles, regarding all the issues, and then they try to develop some consensus and let the field crews operate without any obstacle. And then they carry out the different activities with reference to QC. They just check the field teams and observe that if there is something happening wrong according to the QC's concerns, then they immediately talk to their supervisors. And once all the data is recorded, they receive it, they check it, and they report it to the client. And after that, they transfer the data to the head office of the client. And this is the general overview of the QC site. If we remember the design project snap in the start of the project, which looks that okay, each receiver and source points and receiver lines and source lines, they are at regular interval. Now we can see almost the same thing, the same receiver lines and source lines and receiver points and source points here. But when the survey team and have done their job, they observe different kind of obstacles. For example, they observe that okay, here we have some factory, here we have some houses, here we have some farms, and here we have some different facilities in the area where we cannot work. So they offset the points in some other positions where we can operate. So now once they have done the surveys in that particular area, they return the files of the surveyed coordinates to the QC section, and QC section again plotted that on the software. We have different types of software. Some people use Qlong or KLSize, some people use Visa, some people use Omni. Okay, so when we plot in those softwares, the surveyed coordinates or the recorded coordinates, then we can see that the fold of the particular area is also affected. So the top snap shows us the source and receiver locations after the surveying, and then we can see on the right one we have red and green snap of the fold plot, and on the rightmost we can see a scale that how the folds are distributed along that particular area. If the fold is much affected, then usually we consult it with our client and we want the recommendations. If they say that this is fine, of course that would be fine. But if they say that we can modify this in this regard, then of course we have to do it in that way. And then again we can plot the fold, that's how it looks like, because as much fold we receive, it will be good for our acquisition. We will try our level best to record the data with full fold coverage in the desired area. QC section have, generally speaking, we can say is distributed into two parts. One is the general QC, and second is on-site processing. We have talked about general QC. But when we talk about on-site processing, that this is absolutely a technical job. We have various kinds of the softwares used in seismic data processing. It might be Crasis, it might be GeoEast, it might be Promax, Unega. Different companies are using different GeoCluster. But the objective is same. On-site processing unit they may have one or two processors, and the processor is responsible to keep the data safe and keep the data right on their system. And then they check the data, QC it, check different parameters, and then apply the geometry and check the geometry is working fine or no. After that, this is the daily job. The third step, which is called pre-processing, is comprised of some noise attenuation. If we experience any kind of noise, we will try our level best to attenuate it, and then we can apply velocity analysis. In the velocity analysis, we pick the velocities at maybe 1 kilometer or maybe less or more or less, and then we can stack the data and we can observe some stack with how it look like. If we have some data in the past, then we can look for the brute stack of the previous data and try to correlate with our data that how is the difference and how they are same. This is the basic about the on-site processing. This snapshot shows the offset plot of part of the 3D data. Here we can see 1, 2, 3, 4, 5, 6 lanes, 6 receiver lanes from one 3D swath. On the top we can see one red line, that is basically a mute curve which describes the offsets, that how the data has offset. If there is something wrong, this red line will just move up or down, and which will be a warning for us to get to that point and send that first issue there. And the same thing is also on the downside. We can see one red line, and that red line also distinguish the different receiver lines. This data is the conventional seismic 3D data. But if we talk about some UHP ultra productivity surveys or some DSS, then we can find something very different and very interesting, which will be part of my next videos as well. With the consideration of QC, quality control, I have shared these two slides. The top one is basically a reference sweep traced, and the down one is the data trace. This looks very regular, and we can see that there isn't any fluctuation, so it means this is right. If there would be anything different, if it is a bit fluctuated, then you need to think that what happened, either in the reference file or whatever. So these are the basic concerns about the data channels. Okay, that's the end of my video. If you like my video, please hit the like button and subscribe my channel Science and Innovative Technology. I will be very thankful, and also please hit the bell button so that we will keep you updated about the new videos regarding anything concerning science and technology. Thank you very much.